And this is joint work done with Jenny, Allison, Kapil, Darren, and Hauji. And I'm going to be focusing on the design of opportunistic interactions at distance to support social connection. So over the past year, I've been designing a novel social media application and researching its use in supporting friends who are previously co-located but now don't have the time or means to hang out as often to still engage with each other in shared activities and experiences. I'm going to motivate this work that I've been doing. So, been this this person I can really relate to, and so let's think about. I call him Straightforward Steven, and Straightforward Steven is a user who's did college in Boston, let's say, and he just started a new job in his postgraduate life in Chicago. Not a lot of friends yet, but he had a lot of close friends back in college. And he's wondering how everyone's doing, but he's lost a little touch in the past year as things have gotten busy. But Steven lives in a world where social media is everywhere, and yet surprisingly, things still are feeling lonely. And why is that? Well, when you're connecting with friends at a distance, there's a plethora of social media apps for you and your friends to be on, and yet the evidence for the social benefits of using such technologies is at best mixed. Simple passive engagement with others by scrolling through social media feeds or just browsing others' social news is linked with loneliness and reduced social capital. Yet, if you're able to find connections and directly message or comment on each other's posts, those types of behaviors are linked to positive effects, such as decreased loneliness. Yet, so in other words, this is it's tricky to get this social connection right, and to satisfy our social needs, we need these types of richer interactions. You think, well, I mean, connecting long distance, Stephen, he could maybe video chat his old friends, and that's a good way to be able to have direct conversations. And but at the same time, video calls are one dimensional. It's not a shared activity necessarily. And especially video calls are hard to initiate. It's hard to schedule them, and often there's a little bit of an anxiety to be able to even schedule with friends that you haven't seen in a while if you don't know what's going on in their lives. So instead, we've been looking and considering opportunistic interactions. These are serendipitous moments where, going about our daily lives, we run into each other and are able to share in an experience in the present. In person, it might look like running into a friend in the hallways at a conference, or bumping into a coworker at the water cooler. But not just considering, we're considering opportunistic interactions, not just co-located, but at distance. So what we've been envisioning is what we call opportunistic collective experiences, which are programs that facilitate these opportunistic interactions between people across time and distance. Let me show you an example. I guess I can't show you the example of a video, but here we have a user in Chicago and another person having tea in Taiwan. Because they are sharing a drink at the same time, they can give each other a virtual cheers. So in order to enable these types of interactions to promote social connectedness at a distance, we introduce 3 contributions. One is we developed principles and guidelines for designing opportunistic collective experiences for social connection. Second, we built Cerebro, a computational platform for expressing OCEs and facilitating these interactions. And then third, we studied how The designs implemented with Cerebro and influenced by our design guidelines supported connecting. And we did that by studying examples deployed in the field with distance college alumni. So in designing the guidelines for OCEs to promote social connection, we took a few steps. First, we examined theory and studies for how co-located interactions promote desired social outcomes. Lots of social psychology literature was available, and for example, we've read about how embodied mimicry of others' movements makes for smoother interactions and fosters liking. And second, we tried to reason about how that theory from social psychology, from distance communication literature, and human-computer interaction, all of that can be adapted to connecting in opportune moments at distance. So when we think maybe about what cheersing could look like, but with embodied mimicry applied, we could identify situations that provide a shared context for this type of joint action, maybe a coffee shop and a restaurant that users are drinking beverages, and they'd be able to take this joint action and clink glasses, mimicking each other's motions. We're summarizing these guidelines in two camps. Really, these interactions fall under shared experiences, which at distance look like connecting people who are doing similar activities, but in similar situations, but they're all in their respective individual situations across distributed contexts. You can imagine in three different users across three different places in three different contexts, ramen slurping and being at either ramen restaurants or noodle restaurants, being able to participate. Shared experiences through opportunistic interactions require identifying those situations which afford doing a similar activity like slurping ramen, and in the process of creating that experience, making users aware of the shared aspects of their individual situations. Second, shared goals is an important piece of our guidelines. We're constructing a digital artifact together, or achieving a collective goal by making contributions. People across distributed contexts can feel like their local situations are contributing to something bigger. We could imagine a gallery or collage of photos people contribute, but that form the shape of a heart. Or two distant friends getting to be able to create a photo that is composed of both their local situations. So to enable these types of interactions, we developed also a platform for expressing opportunistic collective experiences, and the goal of the platform was to make it easy to prototype many of these types of interactions to be able to explore the design space that we've been trying to get at with our design guidelines. So in doing that, we, unlike prior crowd programming models that program the assignment of tasks to people, we focus on interaction structures and the situations required for those interactions. Our work has an API for describing experiences, and it focuses on 4 different interaction structures at a high level. The first is related to that design guideline of shared experiences. We'd like to be able to have people share an experience through a shared context at the same time. Think back to that bumped example of the users clinking, cheersing, having a virtual cheers experience, both in Chicago and Taiwan. The second interaction structure is this shared context, but across time. We could imagine users collectively creating a time lapse as they watch the sunset from different places in the world over a week's time frame. We can also participate when users are across different contexts. We could imagine in a parkour competition, there's different challenges, and depending on the user's context, they could fit and uniquely participate in different challenges based on their different situations. The fourth unique interaction structure enables people to build these types of artifacts, but upon which the participation builds on others. So in an example, we could be writing a story together, and suppose a user wrote a sentence about the clouds, which the next person's going to illustrate. Well, if I was that next person and I was participating in a cloudy day, I could illustrate part of that story with a picture of my cloudy day. To enable many of these types of experiences and more, our API has two different constructs. The first is needs, which describe the many shared situations specific interactions take place. This is all it takes to write a situation in which people are bumping for drinking. The second API construct is callbacks. It allows us to update the experiences based on previous participation. When writing that story together, the experience needs to know what the last sentence was so it can set up the next situation for someone to participate. Underlying this API is an engine that coordinates and enables looking for users and recognizing opportunities for these interactions. The engine is composed of three components, which is a user monitor for monitoring users and their changing context, a coordinator which matches those users which we think of as interactional resources to the experiences and potential interactions themselves. And when that matching happens, the executor is able to pair people together, and the experience manager will then progress the experience forward. This is how an OCE might work. Many users are going about their different days and contexts, and one is able to match on an experience for a sunset. By matching to that experience and becoming available, the opportunistic coordination engine sends a notification to the user to tell them to take a photo of the sunset. Opening the notification, the user can participate on their phone, connecting to the camera and taking a photo. That participation will lead to many participations across other users, and all those users will be able to share and create this shared time lapse of the sun. So after designing guidelines and implementing an API which could allow us to explore that design space, we created several example experiences in order to study how those example experiences are able to support social connection. So in a pilot field deployment, at the end of last quarter and the beginning of this quarter, we recruited 31 geographically distributed college alumni. They were given the app over 2 weeks, and we were particularly interested after their use to understand two research questions. One was, how does OCE's design with our design principles help people connect across distance? And the second was, what unique benefits do OCEs provide that are not currently supported by existing social technologies? Our setup was a between subject study in which the experimental condition was mechanism rich, which composed a lot of the design principles embedded in shared goals and shared experiences that we talked about earlier. Compare that to mechanism poor, in which only the shared aspects of a situation are highlighted. Users grouped in these two conditions would only interact with others who received the same OCE version as themselves. So our findings was that users who completed mechanism-rich OCEs, i.e. those OCEs designed explicitly to promote social connectedness as predicted by our design guidelines, those users reported a higher sense of being part of a group. Being part of a group is a social psychology construct called entitivity, and this scale was adapted from other social psychology studies. What we saw was that people in the mechanism-rich condition rated between a moderately and a 3.0 and a 4.0, which is moderately and very, respectively. While the statistical results are not significant, it's close to it, and some components of this entitivity scale, like how much they felt they were on the same team as a friend, were significant. This type of data provides early evidence for people that are able to complete these rich interactions do feel a part of a group and could promote social connectedness, at least reflecting on a single experience. When those same users reflected on their experiences, they were able to attribute some of our mechanisms, such as being able to mimic each other, cooperate on a shared photo, and matching each other's hands in a codependent way, as really influential aspects to making the experience connecting. To answer the second research question, we investigated what kind of effective benefits and costs of communication both existing social technologies have, and after using Cerebro, how Cerebro ranks on that scale. In addition, we ask follow-up questions after the pilot deployment, such as general questions about their enjoyment and use of Cerebro, and specific questions comparing Cerebro to other social technologies. We found that when in the comparison of other people's social technologies that they used before Cerebro and using Cerebro for 2 weeks, that if you look in particular at engagement and play, Cerebro and instant messaging don't significantly differ in rating, which means that OCEs are as engaging and playful as other forms of direct communication, which is great. But other direct communication, as we think back to our persona, Stephen, direct communication is sometimes difficult to make time for, and often there's obstacles with initiating that type of contact. Yet, OCEs are even better at reducing those barriers and reduces the costs of making that type of contact. Quantitatively, measures of unwanted obligations and unmet expectations and even privacy were rated significantly lower for Cerebro compared to other instant messaging platforms. Another finding in relation to Cerebro's uniqueness was that people found OCEs easier to connect with each other, and that OCEs provided opportunities to initiate communication, which can sometimes be difficult if you're both often busy with work. In addition, compared to other social media like Instagram, Facebook, Twitter, and Snapchat, users commented that posting is a really difficult thing on those platforms, but OCEs took away that burden to be able to post something interesting. It took away that self-presentation concerns that other social media does have, and reduces the anxiety and emotional stake of initiating a direct contact with someone. All these are really exciting to see in a pilot study, because what it shows is that there's potential for OCEs to still be directly engaging and intimate, while also being lower effort to be able to initiate more one-on-one interactions with distant friends. And that's our core takeaway, in that OCEs is a really exciting space to continue exploring and studying, as it provides low effort ways to directly engage with others across time and distance. And when we think back to what existing approaches are out there, um, there's only a few ways we're now thinking about connecting at distance, whether that's passive or more active, but higher effort. OCEs represent a space in the middle, and I think OCEs and these results are an important first step in conceptualizing how we can interact at distance. I'm happy to take any questions you have on Slack or other places. My name is Ryan Louie, and this work was done in the Delta Lab and in the Design Technology Research program at Northwestern. Cheers.